This is the Earth Science Classroom. Welcome back to the channel. This video is on differential heating. It is how the Earth is heated in different areas caused by the concentration of the sun's radiation and the solar constant, and how the shape is going to change the concentration in different latitudes. So this video is going to look at the equator, the North and South Pole, the mid-latitudes, and discuss how the Earth has these different areas of concentrated heat. So to look at GCMs and how the atmosphere moves as a large system, we've got to break it down into how this starts and how this initiates. Now, this is called differential heating. Differential heating is how certain areas of the Earth or locations are heated more than other areas. So this is a great example of how the Earth is tilted on the axial tilt inclination, which is 23.5 degrees currently. It does fluctuate, but we have this tilted Earth. This is the cause for the seasons in various latitudes, and the seasons get more pronounced and more diverse with the 4 seasons in the mid-latitudes compared to the more northern latitudes and southern latitudes towards North and South Pole, or towards the equator where the seasons are minimized, or there's only 1 or 2 seasons. So I have this red line showing the equator, which is 0 degrees latitude, and it's at a tilt, an angle, because of the actual tilt, and the Earth spins from west to east, and this gives us our 24-hour day and how the Earth rotates on its axis. So the sun, which is over here on the left, it gives us the solar constant, which is the general average amount of energy the sun puts out that we, the Earth, receive as a planetary system. The energy and EM spectrum and radiation, that is all coming at us, and we receive this energy, and the atmosphere receives it first, and then obviously the surface, both the oceans and land, receive it afterwards. And we do give off some energy, which we know is called albedo. But the energy we keep is what we look at, because the energy we keep in the atmospheric system and the Earth system, the oceans and land, that is what drives our GCMs, our general circulation models in the troposphere and how heat is moved. So around the equator, you have this very direct area that I'm marking out with black right here, that when the radiation hits this area, because the shape of the Earth is an oblate spheroid, it's a sphere, it's a bit fatter around the equator than it is from the north and south, as in up and down. So because this radiation arrives at the Earth in straight lines, the angle at which it hits the equator is close to 90 degrees, as in a right angle triangle. So therefore, the radiation, the energy from the sun, is hitting the equator or the equatorial region at a very direct and concentrated area. So the amount of energy, the solar constant that's hitting the equator is direct and concentrated, therefore it will become hot. Now the same energy that is traveling through space and hitting the north and the south pole at the same time is not having the same effect, because the shape of the Earth is a sphere. And you'll see that the area that the energy is hitting is angled. The energy is going to be spread out over a much larger area in the higher latitudes towards the North Pole, and the same spreading out of energy in the South Pole. That means that there will be less concentrated energy because it's spread out over this larger surface area compared to the equator. And the same thing up here, so it's less concentrated, and therefore it becomes colder because it's less thermal energy because it's being spread out, therefore it's colder. That's why generally the north and south poles are of a lower temperature than the equator. So what we have here, because of the sun's radiation coming in and received by the Earth in a straight line, and the Earth being curved, the surface being curved as the energy is hitting the Earth, it's going to distribute the energy and the heat, so it creates this differential heating, whereby the tropics and the equatorial region is warm and hot versus the polar regions, which is generally colder. Now the area in between 30 degrees north and 60 degrees north and south of the equator, this area is called the mid-latitudes. So generally there is a mixture of warm and cold air, mixing in these locations, causing a lot of the variety of weather we see with mid-latitude cyclones, tornadoes, and hurricanes do start and originate in the tropics, but then make their way into the mid-lats to make landfall in certain areas. So the key is to remember that the equator is hot, the poles are cold because of the Earth's shape and because of the receiving radiation from the sun in straight lines or photons and it being concentrated through different surface areas. So the equator is concentrated and the poles is spread out. This is the Earth Science Classroom. Thank you for watching. I hope you enjoyed the content. Check out more videos on our channel and don't forget to subscribe. Thank you again.